Well, thank you. The two interesting presentations in the same field as I am, not exactly the same field. So my name is Frank Krause. I work for TNO in the Netherlands, and I would like to tell you something about the Rossini-project. This is a project we're in together with Grit, and it is about human-robot collaboration. And we do the part of job quality. And the goal of the platform is basically to develop a hard and software platform that makes industrial robots inherently safe. That's the goal of the project. And we're in it also to make sure that if you apply a human-robot collaboration, that the job quality increases. And we've even promised an increase by 15% to the European Union, because they find it important that job quality is looked after and that it is taken care of. So who am I? Who is TNO? I'm an ergonomist, just like the first speaker, certified ergonomist. I'm also on the Dutch Center for Registration of European Ergonomists. And TNO is a contract research organization. We used to be Europe's second largest. I think we're now third. We do research in almost every field. We do a lot of governmental research as well. The team I work for is called the Human-Centered Technology at Work. And what we do is we focus on three areas. First of all, the exoskeletons. So the first presentation was interesting to me, and we do a lot. We recently did a field study on exoskeletons with plasterers. We do a lot of exoskeleton research. The second one is industrial cobots. Here, a cobot just handing whatever you need to the operator. And the third is what we call operator support systems, where a system with which can be either augmented reality. In this case, it's what we call virtual. No, it's not virtual reality. It's augmented reality, and it projects work instructions on top of the tabletop. But it can also recognize where my hands are. It can show where you need to get your parts, and it recognizes if I've been with my hands in the part. And like Teresa said in the last presentation, we are also looking at ways to make this system adaptive so that it only gives you the information you need and doesn't bore you with information you already know. So that's about me. This is about TNO. About the Rossini project, as I said, the aim is to develop a hardware software platform that's inherently safe, and it consists of several layers. But for me, the most interesting one is the human layer, and that's what we are in the project for. Now, why collaborative robots? Well, first of all, the workers will not disappear. That's what we're often afraid of with robots, but workers will not disappear. We believe that human beings have such unique capabilities that it's better to focus on working together with robots. Robots are extremely good in repetitive tasks. They're extremely strong. You cannot bore them. You cannot fatigue them. That's great. That's what they can do. But the workers, they have extremely fine motor skills. They are creative. They are flexible. They're social. And you should use both in work. And the other reason why we should have collaborative robots is, well, it's better to have safe robots with unsafe human than the other way around. Because if you can program a robot to be safe, that's good. But I don't think we could ever program a human to always have safe behavior. So that's why better to focus on collaborative robots. And that's what we're doing in this project. But what has this to do with job quality? Well, first of all, robots change work, and so people are afraid of job loss. Robots change the work. They don't always replace the worker, but they change the work as well. And it could be for worse, and it can be for better. So at least we have opportunities. We have opportunities to reduce physical loads, and we have opportunities to maintain or improve working conditions. That's not new, by the way, because just like machines, robots change work. Machines have always done this. They've always been a competitor to the human. And in the first industrial revolution, what they did is they basically changed. What they did is they supplied us with the power, so that the human didn't need to supply the power anymore. In the second industrial revolution, we see that the robots, they're providing the thinking power we have. So the machines can do more and more. We have automation, we have robotization. The next step is artificial intelligence, and that's when the robots will also try to be as unpredictable as we humans are. So this is happening all the time, and this is why we need to have a good look at the robots, and especially to try to prevent that introducing robots makes the work worse. Let us first look at the concept of job quality. What is it? It was specified by the OECD, the Organization for Economic Cooperation and Development, and it has several parts. So it's about earning quality. It's about labor market security. This is something we cannot influence, by the way, in our work. So it's not part of our project, but it's also about the quality of the working environment, which has, just like in one of the previous talks, you have demands and resources. Here are the demands. These are the work stresses. So it's time pressure at work, physical health, risk factors, and workplace intimidation is also a stressor. And you have workplace resources. Not all can be influenced by human-robot collaboration. We focus basically on these, but you could also think that maybe these can also be affected by human-robot collaboration. I mean, in some ways you might feel intimidated by the robot, and it might provide you more learning opportunities. And who knows, that you can get a bond with a robot, so you feel that, okay, I have a new friend on the work floor. That's exactly what we want to do. So how could robots improve job quality or make things worse? First of all, we have examples. They're very good at taking over and supporting physical tasks. Heavy tasks like this one, the palletizing robot, or the spray painting robot, which takes over repetitive tasks and also takes care of the bad postures that spray painters are often in. So we reduce shoulder complaints. So that's good. And this is maybe one of the first collaborative robots. It's an AGV, automated guided vehicle, or nowadays sometimes called automated intelligent vehicles. And what this robot does, it brings the goods to the person instead of the persons having to go to the goods. So that means it's less pushing and pulling, but it also means less walking. And that's good for productivity. But is it good for job quality? We'll take a look at that later. And we also even have, so robots are getting closer and closer to us. We even have wearable robots to support us. This is a robot which is used by Japan Airlines, and it supports our back when we do heavy lifting. So if we look at this, we could think that the effects so far, this is what we expect. Workload, physical workload should go down. Let's have a look if that is really happened. What are the effects on job quality from collaborative robots? Well, if we look at physical workload, we have seen that they can reduce overload. Sometimes they can bring more variation. But if we look at the statistics, then there's not so much change. From 2005 to 2015, these are Eurofound figures. Tiring, painful positions, no change. Lifting, hardly any change. Carrying or moving heavy loads, no change. So it's no change at all. That's typical. from a robot that can take away so much load. Now let's look at other aspects as well. Cognitive workload. This is what we could achieve. So with these cognitive systems, we can achieve that we can supply cognitive support, which means people make less mistakes. That could be very positive. We can even supply cognitive support. That's what we have done a lot in projects the last couple of years, to people who have some form of disability, and they are suddenly able to do a lot more than they could do before, which is very positive. Psychosocial factors, if you can make a robot be a reliable partner, that's positive. If you can keep the human in control, that's positive. Environmental factors are less of an issue here, so I'll skip that. Unfortunately, we also see a lot of negative effects from robots and collaborative robots on job quality. If you take away too much physical load, you will get underloading, which is something we don't want either. You might go from a dynamic workload to a more static workload. Like if you used to walk around to collect your goods, your orders, and now you're standing at a station and everything's coming to you, that's more static. That's not positive. We might see more repetition. Cognitive workload, we might get too much simplification, or we might just be monitoring tasks because the robot's doing everything. Psychosocially, you might have a loss of a sense of control, or you might really lose control, get more work pressure. I'll show you that later. And you might get you might have a lack of trust because you don't trust the robot. We might even introduce more noise. So it's not just positive. We need to take care that it doesn't get worse. So how come we also see negative effects? That's first of all because robots cannot do everything. So we still need the human to perform certain tasks. And which tasks is something that the robot doesn't design. The robots doesn't design the work. They don't design the work. So who's responsible? We are. I mean, those who design the work, the engineers, the managers, but maybe also the ergonomists, we are responsible for designing the work. So are we doing things wrong, or how can we do it right? Well, first of all, generally, this is the focus we're on, system optimization. But what we need to be careful for is that we just don't focus on only this system, the technical system, because the system is bigger. We have a human working with this system, and this is the first technical system, the first system we need to optimize. Take the human into account. That's what the former speakers also said. But we should even go further, because we should look at the complete system, the complete work system. And this is an example of Amazon. And what you see here is, for instance, this is the worker in a completely isolated workstation. They used to walk around through the logistics center, come into contact with people. They're now completely isolated. Amazon has introduced a game that stimulates the worker to work harder and harder. So so robotics can also be used against the worker. We are looking at system optimization in its completeness, and that's what ergonomics is. We always say it should be sustainable productivity. And from a socio-technical point of view, what you could also say is a system or a work change is good if it is good for the company, good for the self-steering team, and good for the individual. All these three should be achieved. Now let's look at job quality in Rossini, in the Rossini-project. We're looking at system optimization from 2 points. First of all, the design, and we're looking at the communication design. The robot human mutual understanding. That's what it's called in the project. Why communication? And the communication, we have to think about in its broadest sense. So it's verbal communication, it's maybe through an interface, but it also can be non-verbal communication. So the first point of communication is that if both human and robot understand each other, it's a lot safer. If I know what the robot's going to do, I can anticipate. If the robot knows where I'm moving, where I'm going to do, it's safer. And it's more efficient. Because if I think that the robot is going to do something and it's not doing that, I'm waiting. So good communication is more efficient. That same works inside a good working team. It can be social. It leads to trust. If I know what other people are going to do, if I'm if the robot, well, the robot doesn't have to trust me because it's a robot, but I need to trust the robot. And for that, I need to know what it's going to do. It needs to be predictable in a way. And very important from a human factors point of view, I need to feel that I'm in control. So in this human robot collaboration. The second part is on the task design and management. We have built a tool. It's still in the prototype phase. We have built but 2 tools still in the prototype phase. And the first tool is a design tool, which aims at designing the task allocation between the robot and the human. So who does what at which given time? I'll get to the process management tool later. In a way, this tool is a bit strange because what it actually is it tries to robotize the ergonomist. It tries to because it provides all the information to the engineers, and it's during the design process of this tool, it was very difficult for me as an ergonomist to try to put all this information into a design tool and to sort of robotize myself. So yes, I too can be afraid of robots. And by the way, what the design tool also does is not just focus on the human-robot collaboration, but also on the tasks that the robot needs to do, that the human needs to do, that the robot isn't doing, because that too can be a problem. Because I'm left with all the tasks that the robot cannot do, and they're not necessarily nice tasks. So what does the design tool look like? This is just an overview of the screens. We have a task panel, step tabs, information panel. That's not important. The most important part is the process. And the process is, first of all, you start with a task analysis. This is what every ergonomist starts with. Describe the processes and the tasks. The next point is we ask you to define task allocation scenarios. What few scenarios of what the robot and the human will do. And then we select job quality parameters and we score these. So for every scenario, we think of first for the baseline and for the scenarios, how good or bad is the physical load? How good or bad is the cognitive workload? And this is just a judgment, and you can assess them with tools as well if you like. And then the tool visualizes the results. And what can you do with this? Discuss. And that's exactly what we want to do with the tool. That in the design stage, you discuss whatever you plan to do with the stakeholders, so with management, with engineers, but most importantly, also with the workers. Task analysis. So what you first do is you list all the activities that are possible. This is an example of mounting a counterweight in a washing machine, which is, a washing machine, the counterweight is quite heavy. You can use a balancer, but balancers are often too slow. And if you can lift it, then generally workers will lift it unless there are very strict procedures in the company. So we're looking at applying a collaborative robot in this work situation. This is one of the use cases in the Rossini-project. And we listed the task, we listed the task durations, and we assessed each subtask on physical loads, cognitive loads. So eventual psychosocial aspects and environmental aspects, as far as possible, I must say. And then the tool shows you this. It's a sequencing. So these are all the tasks the robot needs to do. And then at some point, the human can take over the counterweight and do its thing. And this is a second task, second scenario. In this case, the robot brings the counterweight to you, but it keeps hold of it, and the robot guides, and the human guides the robot to the washing machine and then fits it, and then it's all connected. Now, this is interesting. This looks like a longer sequence than this one, but if you put them behind each other, then suddenly scenario 1 is quicker than this scenario. And most importantly, this scenario has waiting time for the human. And this is something you don't want, because waiting time for the human, first of all, it's not productive. And second, it can be it can trigger the human to perform behavior you don't want, because in this period, the human will walk away and do different things, or it might take over tasks from the robot. So you don't want waiting time. So this is what the tool shows you, and you can evaluate these scenarios. The tool also shows you job quality visualization. And this is the base scenario where you see the dark red spots, heavy workload, because they sometimes lift these counterweights. And in scenario 1, you still have some physical load from the counterweights, because in this scenario, what the robot does is it puts the counterweight in a very optimal position in front of you, but then you still pick it up, but in an optimal way. And in this scenario, you don't lift it at all. But in this scenario, it takes longer, and you have waiting time. In this scenario, you still have a little bit of physical load, but it's quicker. So this is something that an ergonomist is used to do together with in a design team. You evaluate the different scenarios and you choose. And we can try to achieve this one, but it's not realistic. If the productivity goes away because it's too slow, even though it's good for the operator or there's no physical load, it won't work. So then sometimes scenario 1 is even better. Now, that was the design phase, and the next phase is deployment. So we have the robot and the human working together. And in this situation, what the management tool does, it monitors both the tasks performed by the human and the robot. And at a certain point, it can give the task to the robot and to the human, because maybe the robot's too far away or the human is too far away to perform the task. And if it wants to give the task to the human, it will always check how much physical load has this person had, how much cognitive loading maybe has this person had. So it checks certain parameters, and based on this, the task scheduler will decide whether the robot will do it or the human will do it. Right now, in the phase we're in, this is a prototype. Because of COVID, we haven't been able to test it yet, but hopefully after the summer, we'll be able to do prototype testing and to see how good it works. To finish, what are my key points? Cobots are our future, so we better learn to live with them, but design properly. When we design, we should aim for work system optimization, not technical system optimization. And we should do so early in the design phase, because in the early phases of the design, we have a whole lot of alternatives, design alternatives, but the further we get from the development, deployment, the number of design alternatives, they go down rapidly. And the costs of change, they go up steeply. So this is where we should make our design choices. User involvement, that's what any ergonomist likes. And if you don't have an expert in-house, we always say, well, try to get one. Any questions?